All right, taking a look at 7.4. 7.4 introduces what they call specialty right triangles. Right? We're going to go over both of them here today, and it really works with being able to find the missing sides of your triangle if you only know a certain amount of information. So as we've dealt with all of Chapter 7 so far, Chapter 7 has dealt with our right triangles. Right? So in 7.4, we're going to deal with these specialty right triangles. Right? The first one we're going to deal with is what's called a 45-45-90 triangle. And it talks about the measurements of your angles. Right? We know it's 45 degrees there for angle A because all of our angles have to add to 180. Now, earlier this year, we talked how since these two angles are equal, then these two sides have to be equal. So I have side BC being 3. That means side AB is 3. Well, that leaves me with side AC to find. As Pythagorean theorem tells us that in this triangle, x squared will have to equal 3 squared plus 3 squared. So x squared will equal 9 plus 9, which is 18. When we go to solve our equation, then, we must take the square root of each side to solve for x. So we have this answer of x equals the square root of 18. Here's where we have to be careful with the directions. In our directions here, they say to leave your answer in radical form, meaning I have to look to reduce this square root of 18. So you are looking for a perfect square that goes into 18. A perfect square that goes into 18 is 9. 9 times what? It is 9 times 2. We pick 9 because you know the square root of it. The square root of 9 is 3. So we have 3 times that square root of 2. That is our other side. If you look at your lengths here, we have 3, 3, 3 square roots of 2. In a 45-45-90 triangle, that will always be true. If I had 5, for instance, it would be 5. This side would be 5. This side would be 5 times the square root of 2. If we had 7, this side would be 7. This side would be 7 times the square root of 2. That relationship will always be there. That is why it is known as a specialty right triangle. Right? In that case, in that 45-45-90 triangle, that triangle will be isosceles. It is a triangle that has two congruent sides, and that 45-45-90 talks about it being two congruent angles. Now, in a 45-45-90 triangle, there are two distinct possibilities. Option 1, they're going to give us the leg, meaning like we had in the opener, this leg was 3, this leg is equal to it. Then to get the hypotenuse, we said it would be 3 square roots of 2. So if they give me the leg, we are going to multiply by the square root of 2 to get the hypotenuse. If we wanted to go the other way then, if they give me the hypotenuse instead, to get back to the leg, we'll do the opposite operation. We will divide by the square root of 2 to get our leg. Right? So this is our first of 2 specialty right triangles. Your 45-45-90 triangle. It says in a 45-45-90 triangle, the hypotenuse is the square root of 2 times as long as each leg. So really they are going to give you 2 options here. They're going to give you a leg and you multiply by the square root of 2, or they're going to give you the hypotenuse and we divide by the square root of 2. So let's take a look at our first few examples here. In our first one, it says find the length of our hypotenuse. So 45, we know this angle is 45. So the very first thing we can do is those sides have to be equal. So if the right-hand side 6, the left-hand side 6, to get the hypotenuse, you take your leg and we multiply by the square root of 2. So we have 6 square roots of 2. Now, I cannot multiply the 6 and 2, so I'm truly done. It is in B that we actually have to worry about simplifying our answer. We'll take a look at exactly how to do that here. Here they give us the legs that are equal. So it's 45, 45, 90. If they give you the leg, we take whatever that leg is. Here our leg was 6. So we took the 6 and we multiplied it by the square root of 2. That's how we got our answer. Here we're going to take our leg. Our leg is 4 square roots of 2. And we are going to multiply it by the square root of 2. Now here we actually have to clean some things up. Your rules for multiplying radicals. Numbers that are outside can get multiplied with numbers that are outside. Well, the number in front here is understood to be 1. Just like it was 1x would represent just x. Numbers that are outside can get multiplied with numbers that are outside. 4 times 1 is 4. Numbers that are underneath can get multiplied with numbers that are underneath. 2 times 2 happens to be 4 also. So we have 2 times the square root of 4. However, we know the square root of 4. The square root of 4 is 2. So I have 4 times 2, which tells me my hypotenuse is actually 8 units long. So truly, we're just working with those radicals that are there. That's the only way I can make these 45, 45, 90 degree angles any harder, is to make you simplify your radicals. Right? In example 2, now they want me to find the length of our legs. So here they give me the hypotenuse. If they're giving you the hypotenuse, then to go backwards, we divide by the square root of 2. So I take whatever the hypotenuse is, I take whatever that hypotenuse is, and I'm going to divide it by the square root of 2. Now, it just so happens here, the square root of 2 divided by the square root of 2, they cancel each other out. So we end up with 9 for the lengths of our legs. Notice it is 9, 9, 9 times the square root of 2. So the key in these problems is identify, are you given the hypotenuse or are you given a leg? So here we are given a leg. The legs are equal. To get the hypotenuse, you take your leg and we multiply it by the square root of 2. So I have 2 times the square root of 2 times the square root of 2. Numbers that are out in front get multiplied with numbers that are out in front. So that's understood to be a 1, so it's 2 times 1 is 2. Numbers that are underneath get multiplied with numbers that are underneath. 2 times 2 is 4. So I have 2 times the square root of 4. Well, we just happen to know what the square root of 4 is. Square root of 4 is 2. So we have 2 times 2, which gives us 4. Looking at your next one then. Now I have my hypotenuse. To get back to my legs, we take whatever that hypotenuse is, and we divide it by the square root of 2. Here my square roots of 2 cancel each other out, and I'm left with 12. Right. Now there is one other possibility that we need to explore. Here, when I divided by the square root of 2, they canceled each other out. What happens if they don't? For instance, here. Here I am given the hypotenuse. To get back to a leg, I have to divide by the square root of 2. So I take my hypotenuse and I divide it by the square root of 2. Now it doesn't cancel out. But I do need to do something to it. I can't just leave it like this. For reasons you'll get into in Algebra 2, I am not allowed to leave a radical or a square root symbol in the denominator of a fraction. It creates all these errors in what I'm trying to do. Right? You'll get into that in Algebra 2. But for now, what you need to know is I'm not allowed to leave that square root down there. So there is a way to get rid of it. The way to get rid of it is we multiply the top and the bottom of our fraction by whatever's there. Whatever is down here, I multiply the top by it and the bottom by it. If it was the square root of 5 that was down there, I'd multiply the top and the bottom by the square root of 5. If it's the square root of 3 down there, I multiply the top and the bottom by the square root of 3. Here's the square root of 2. Then I just follow my rules for multiplying with radicals. So multiply across the top. We do 6 times the square root of 2. I got a number outside and a number underneath. I cannot combine them, so it stays just like that. Here on the bottom, we have the square root of 2 times the square root of 2. Both 2's are under a radical, so I am allowed to multiply them to get the square root of 4. Now, the whole purpose in doing this, you should always know the square root of this value. That's the whole reason we're doing this, is so that we can make this a whole number. The square root of 4 is 2. Last thing to do is see if your fraction reduces. Right now we have 6 over 2. 6 over 2 does reduce to 3. So there is our answer then. That is the hardest problem I can possibly give you in a 45, 45, 90 triangle. The other figure we're going to work with, our other specialty right triangle, is going to be known as a 30, 60, 90 right triangle. And the reason we do it and the reason we call it that, I have my 90 degrees. It's a 30, 60 right triangle because one of my angles will be 30 and one of them will be 60. Now, when we look at this right triangle, we need to be able to establish what side is the smallest side. The smallest side is opposite the smallest angle. Smallest angle is 30, so the smallest side would be the side opposite 30. We call that X. We call that our plane side. Everything will relate to it. Your hypotenuse will be twice as big. So your hypotenuse would be 2 times X. So if X is 5, for example, 2X would be 10. It would be twice as big. Your other side, the one that is opposite of 60 degrees, so this side on the bottom, it takes whatever that X is and it multiplies it by the square root of 3 instead. Right? So if X is 5, then this is 5 times the square root of 3. Just to take a look at one more very basic one, I'll make this my 30-degree angle now. This is my 60-degree angle. They all relate to now my small side would have been at the bottom. So if this is 10, right away we know the hypotenuse is 2 times as big, so it is 20. Your other side then, the one opposite of 60, takes whatever that small side is, and it multiplies it by the square root of 3. Right? So that is what our 30, 60, 90 triangle looks like. It says in a 30, 60, 90 triangle, the hypotenuse is 2 times as long as the shorter leg. So that's why we call it 2x. And the longer leg is the shorter leg times the square root of 3. That's why we called it x times the square root of 3. Now, in these problems, the 2 examples we've done so far, I gave you the shortest leg. If they don't give you the shortest leg, we must find it first. We'll talk about what that means here as we go through some of these problems. Right, a couple last examples to look at here. First one says you make a guitar pick that resembles an equilateral triangle with a side length of 32 millimeters. It says what is the approximate height of the pick? So if you notice, I end up with this right triangle here. It is a 30, 60, 90 right triangle. I'm going to pull it down here and redraw it. 90, 60, 30, 16, 32. So when we talk about our places, we have an x value that is opposite of 30 degrees. We have an x square root of 3 that is opposite of 60 degrees. We have a 2x value that is opposite of 90 degrees. So here, for example, if they gave me the 32, That's opposite of 90 degrees. That's my 2x value. That's our hypotenuse. If they do not give me the x value, they give me an equation to solve. 2x equals 32. Well, if I divide both of these by 2, then I'll know what x equals. X equals 32 divided by 2 is 16. So x is 16. That should make sense because opposite of 30, they already told us was 16. Our last one then is this height, this x square roots of 3. It says take your x value, which is 16, and multiply it by the square root of 3. Now, I am not allowed to combine these terms. There's no way to simplify it. So I do end up with just 16 square roots of 3 for my height. Right. Let's take a look at our next problem then. Very first thing I want to point out, if they put an x in your picture, we're going to get rid of it. We're going to change that variable. We'll make it something else. Just that way we don't get confused with the x's in our chart and the x's in the picture. So instead of finding x and y, we're going to find z and y. It says write your answer in simplest radical form. So I do have to work with these radicals. Looking at my triangle, the only value they give me is 8. 8 is opposite of my 60 degrees. That is our x square roots of 3 value. X square roots of 3 equals 8. If they don't give us x, they give us an equation to find it. So they are saying here that x square roots of 3 equals 8. I need to solve that equation for x so that I can find out what x equals. To solve for x, then we divide both sides by the square root of 3. So these cancel out. I have x equals 8 over the square root of 3. Now, as we talked about, we are not allowed to have a radical in the bottom of our equation. So the way we get rid of it is we multiply the top and the bottom by whatever was down there. So since it was a square root of 3, I am multiplying the top and bottom by the square root of 3. On the top, the 8 is outside, the 3 is underneath, so I must leave it as 8 square roots of 3. On the bottom, the 3 is underneath, the 3 is underneath, so I am allowed to multiply those to get the square root of 9. Now, the whole point in doing this is we are supposed to be able to know the answer to that square root of 9. Square root of 9 is 3. Last thing to check is, do these numbers outside reduce? Do 8 and 3 reduce? No, they do not. So I have x equals 8 square roots of 3 over 3. So going back to my chart then, x was 8 square roots of 3 over 3. So for 2x then, it is 2 times 8 square roots of 3 over 3. To multiply by a fraction, we just make our 2 over 1, and we multiply across the top, and we multiply across the bottom. So we have made this little chart. That is my advice to you every time. Make yourself the little chart so you know what pieces you have. So opposite of 90 goes our 2x. Well, that's where our y was. So this is 16 square roots of 3 over 3 is y. Opposite of 30 is my x value. So z is going to be 8 square roots of 3 over 3. This is as hard of a 30, 60, 90 problem as I can possibly give you. A couple last examples to look at here. In our first one, it says a car is turned off while the windshield wipers are moving. The 24-inch wiper stops, making a 60-degree angle with the bottom of the windshield. It says how far from the bottom of the windshield are the ends of the wipers. So we want to know this length right here. I'll call it h. This angle down here is 60 degrees, so this angle up here is 30 degrees. Just if I wanted to blow this up, make it bigger, I got 60, 90, 30, 24, and I'm trying to find h. First question you need to ask yourself, do you know the side that is opposite of 30, which would have been down here? Do you know the side that's opposite of 60, which would have been here? Or do we know the side that's opposite of 90, which is here? We know the side that is opposite of 90, so we know our 2x value. 2x equals 24. If 2x equals 24, we need to find x. This is just an equation. So we divide both sides by 2. We get x to equal 12. Well, that means that opposite of 30, x is 12. So this side down here is 12. That's not the side they're looking for, but that's the side we have right now. Opposite of 60, then, is whatever x is. We just said x was 12 times the square root of 3. 12 times the square root of 3. The 12 is outside. The 3 is underneath. We are not allowed to multiply those. So it truly is just 12 square roots of 3. That goes opposite of 60 then. That is the length they were actually asking for. All right, 3 problems left. Take a look at the first one. First thing, once again, to do, we need to realize, do we have, once again, I have the x there. We're going to get rid of it. We'll make it y in this case. Do we have our x, which is opposite of 30? Do we have our x square root of 3, which would have been opposite of 60? Do we have our 2x, which would have been opposite of 90? Looking at our picture, we have 2 square roots of 3. That does not mean we have this value. Look what it's opposite of. It is opposite of 30 degrees. So that is our x value. X is 2 square roots of 3. So to find 2x, that is 2 times whatever x was. That's 2 square roots of 3. Numbers that are outside get multiplied with numbers that are outside. Numbers that are inside, I only had the square root of 3. Right? So that goes opposite of 90. So that would have gone here if they had asked for it. The x square roots of 3 says you take whatever x is times, so x times the square root of 3. Numbers that are outside, you multiply with numbers that are outside. Numbers that are underneath, go with numbers that are underneath. The square root of 9, we know to be 3. So 2 times 3 is 6. So 6 goes opposite of 60 degrees. So as it so happens, y is 6. Take a look at your second one then. I do have it on a different screen. It's the same problem. First thing to realize, I got 12. This bottom side is 12. It is an equilateral triangle, which means all of your big angles here are all equal. They're all 60 degrees. So when I have that height then, I got the 12 here, I got 90, I got 60, I got 30. And it just so happens I got 6 also. Looking at my 3 sides, x square root of 3, 2x. Opposite of 30 is 6. Opposite of 90 is our 2x. That's our 12. The piece we still need is the one that is opposite of 60. That would be x times the square root of 3. So it is 6 times the square root of 3. I cannot combine the 6 and the 3. So my height they are asking for, I am just going to write it as 6 times the square root of 3. Last problem then. It says, in example 5, how far from the bottom of the windshield are the ends of the wipers if they make a 30-degree angle with the bottom of the windshield? So once again, we have my 24-inch wipers. Now this angle is going to be 30 degrees. They want to know our height. We are, not 24 degrees, sorry, 24 inches. We know opposite of 90. We know our 24. So we know our 2x is 24. So once again, if I divide by 2, we get x to equal 12. Which means x square root of 3 will take my x times the square root of 3. The x goes opposite of 30. Opposite of 30, this would be 12. The x square root of 3 goes opposite of 60. So this angle up here would have been 60. So this side down here would have been 12 square roots of 3. And then I have my opposite of 90 was our 2x. That was our 24. Which length do they want now? They want the height of those windshield wipers. They want this length right here. So that would be 12 inches. Right, so those are our two specialty right triangles here. All right, your homework is there, pages 461 to 462, the numbers you see there. And then we'll talk about our 7-1 to 7-4 quiz in class. All right, let me know if you have any questions.